In the last video, we have done how the equation of a plane looks like, correct? And the two different forms, like intercept form we did, different forms of plane. Now this in this particular video, what we are doing is, suppose say you have two planes. Okay, so assume that the two planes are like this. Okay. Now what if there is another plane which is passing through the intersection of the plane? How the equation of the plane is going to be? Fair enough. In the sense, what we are doing is intersection of two planes. So here, let's assume, okay, so assume that you have one plane which is going to be like this. Okay, let's call this as pi 1, assume. Now, let's say you have another plane which is passing through the intersection. In the sense, suppose say you have another plane something like this. Say this is pi 2. Okay, now you see the intersection of these two, isn't it? See, this is the intersection of these two planes. Now, within, like on this intersection, what if another plane passes? How we are going to find the equation of that particular plane? That's what we are doing in this video. Alright, that means here, so assume that we are going to have another plane which is passing through this particular plane, the intersection of the planes. Clear? Say, let's call this as pi 3. Now, pi 1, say the equation, remember we'll start with the vector form, then we have the Cartesian, we have two forms, correct? Now, in the vector form, pi 1, when you take, we can say r dot n1 is equal to d1, correct? R dot n1 is equal to d1. The second one, pi 2 is equal to r dot n2 is equal to d2. Now we have two planes, r1 dot n1 and r dot n2. These are the two planes. Now, if they are intersecting, now if you look at this, the intersection of two planes is going to give you a line, correct? Look at the figure. Guess it's very easy. Suppose say you have two lines. When two lines intersect, that is going to give you a point, correct? Like this, you are going to get a point. If two planes intersect, then what's going to happen? You are going to get a line. See, this is a line, correct? So what we have is a line and a plane pi 3 is passing through the line. Now let me repeat this one more time. You have pi 1 and pi 2, which are two planes. Now intersection of these two planes is going to give us a line. Now another plane pi 3 is intersecting these two planes, in the sense the plane pi 3 is passing through the line which is created by the intersection of pi 1 and pi 2. Correct? This is the meaning of this, whatever I was trying to explain it to you. Now, the plane pi 3 is passing through the line, isn't it? So, what we can write is that what if you do this r dot n1 plus lambda into n2. This will be equal to d1 plus lambda into d2. Now, why are we doing this? What is the reason behind this? Very simple. The reason why we are taking this and when we are adding this one, the reason is, now any plane parallel to the plane that can also give the same result, correct? Say this is one plane, r dot n1 is equal to d1, assume. Say this is r dot n2 is equal to d2. Now they are not intersecting. But the same thing if I keep on taking parallel, so somewhere here they are going to intersect. That means it need not be the same plane. It can be any plane parallel to it. That is also possible. That's why we take r dot n1 plus lambda n2 is equal to d1 plus lambda into d2, where lambda is any real number. Fair enough? Any real number, lambda can be anything. Now, this particular value, what you have, r dot n1 plus lambda into, this is going to give us the equation of the plane which is passing through the intersection of the two planes. Okay, now you might be thinking like, How did we get this? Like randomly I wrote something and like how are we getting the value? Now for that, let's look at the logic behind this. Okay. Now you know that the point, not the point, the line which is being created by the intersection of planes, that is has to pass through some point, correct? Say that arbitrary point, some arbitrary point, say that is T, assume. Okay, now T is a point on the line. And where is the line created? Line is between the pi 1 and pi 2 if you look at that one. That means T is a point on both the planes pi 1 as well as pi 2. Make sense? That means for the first equation we are going to get T dot n1 is equal to d1 because it's there on the first plane. Likewise, T dot n2 is equal to d2. It's there on the second plane also. Since it's a common point between these two and a line passes through this particular point, we can, you can do the equation of the line in the vector form, isn't it? In the vector form, what was it? A plus lambda b, isn't it? A plus lambda b. So in place of A, you can write this T, isn't it? So since we can write in terms of A, we can write it as T. So what are you going to get? You'll get T plus lambda into B is equal to 0. Of course, A plus lambda B is equal to 0 or T plus lambda into B is equal to 0. Now this is going to give us the equation of the line, which is the intersection of the two planes. Correct? Now this, the third plane pi 3 is going to pass through this particular line, isn't it? So since we have this T plus lambda into B, this is where the lambda value is going to come. Fair enough? So from this equation, we'll get R dot n1 plus lambda n2 is equal to d1 plus lambda d2. Fair enough? So this is going to give us the vector form of the plane, equation of the plane passing through the intersection of two planes. Now same thing if we have to do by the Cartesian method. We'll look into that now. In the Cartesian form, see what we'll do, we'll take the equation of the plane. Okay, so equation of the plane, say pi 1 is equal to a1x plus b1y plus c1z plus d1 is equal to 0. And say pi 2 is a2x plus b2y plus c2z plus d2 is equal to 0. Now what are we doing? We are adding these two, correct? So see how it's going to be pi plus lambda into pi 2. This is the value of pi 3, isn't it? That's what we did in the vector form also. So you're going to get a1x plus b1y plus c1z plus d1 plus lambda. So lambda into the same thing, isn't it? So we are going to get a1 plus lambda a2 into x, because here you are going to have a2x here, correct? So in this and then this, take x common, a1 plus lambda into a2. Likewise, plus b1 plus lambda b2 into y plus c1 plus lambda into c2 into z is equal to d1 plus lambda into d2. Or you can also write the same thing here. See, instead of is equal to d1 plus lambda d2, you might be thinking, shouldn't it be minus d1 minus of lambda? Guys, d1 and d2 are just constants, right? So we are just pushing it that side, that's all. Okay? Or if you want to write everything together, then you can write this as plus this is equal to 0. So this gives us the equation of the plane intersecting the two other planes and in the Cartesian form. Clear? So these are the two equations what we have to look at.